It's time to start this discussion on OpenNMS map use cases 2015. So I'm Antonio, and it's more than 10 years that I'm involved in OpenNMS, and with the, how to say, special focus on topologies and maps. I remember my first dev jam, I come there and I just contribute the SVG maps and the linkd. And Tars says, I hate maps. And it was, well, it was a problem for me because I was not really happy for this statement. But at the end, I hate map too. So it is very easy to fail a project, especially, how to say, if you build your map apps by yourself and someone uses it, is okay. But if you try to build a map app for a special user, he is always unsatisfied of what you have done. So first of all, we have to address this problem. Why people are not really all that happy about network device maps. And that is the first point in this presentation. So I don't know, it's just this was something old by Genesis. I know what I like and I like what I know. This is the problems of the maps. So everyone has, when he says, oh, I want maps, it's just a generic request, but everyone really does not know what he wants, because there is a lack of knowledge and a lack of understanding about network maps. Because networks, and especially, how to say, IP device network, are complicated objects. Okay, you can have, and so we have to, how to say, manage this complexity to let the people be happy. Let's move on the, try, it does not work, so I have to do this. I have something like a browser here. So I don't know if you can see. If I search for network maps, okay, you will find a lot of this information. These are the tops of the maps, okay? And you can see what you see in this picture. You see a wide variety of maps. These are all network maps, okay? So you can have that kind of map, that kind of map, that kind of map, that kind of map, everything. So the first problem, everyone has built his own map. There is no common, how to say, framework for display maps. So when you say network device maps to the people, they can just think to this, they can think to this, they can think to this, they can think to this, or this other one. So what have they in mind? How is possible to how to say, have a map that is able to do all these things? So the first real problem is that there is no standardization, and the maps are all about education and standardization. I will try to make another search. Okay, and should be do you see? So these are also very vintage old maps. But do you see the difference? So you understand that this is something that has built in the years with strong conventions. And usually these nautical maps are useful for navigation, and they are very important. And they were extremely important in the past, but actually you do this, and usually the governments publish this under very strictly condition. So because everything they put on the map means something. So you see, let me say, it's clear that there is a standard here. So we have 500, maybe 1,000 years experience and work on the maps, because the maps are very useful, because the maps are very, how to say, simplify the situation. They let you understand everything. And on the other side, we have the 30 years history of network maps. That's it. So I just want that you take also a look at because this confusion is always on Wikipedia. So if you go there, you see, let's first of all see this one. So this is network mapping. I hate this. And if you look at this picture, this is a picture of the internet. So we have another interesting situation here. And here is what this picture means. And it's clear that only people with the skills in statistical mechanics, and it was called complex network theory, can have an understanding of what this object means. This is a meaningful map of the internet, and one that has a well-educated way of looking at this kind of maps. You can say, well, it seems like a scale-free network. So there is a strong classification in this direction. This does not mean nothing for the most part of the people. So this is another great problem in maps, that we have to work on education of the people. This is normal. When we spend a lot of time in school studying geography, and the most part of geography is made of maps, so we know automatically the conventions for the map. Okay, but we don't have any yet conventions for network device maps. So is there an icon that clearly states that this device is a router, and this device runs BGP or SPF and whatever else? So just telling something more interesting, the truth, we have, how to say, some standardization that was made by Cisco. So Cisco has a standard way of representing objects. So we can use Cisco library. The point is Cisco library enough for showing the network? I don't think so. So the real power of the maps is the following. Put a lot of information on the maps and express this information using graphical signs. Okay, that's what we should do. So our perspective now must be this one. And we can try to, how to say, work with this and in OpenNMS to understand what can be, how to say, a solution for this problem. You see also here that depending, so this is the way, why I'm looking at Cisco maps. And Cisco is a very big company and had made in the past a lot of training. When I started working on this stuff 20 years ago, it's the people knowing a TCP/IP as protocol or just routing or something like that were not all that much. So the people learn in the time. And Cisco was the company that, how to say, just boost with the network. So they were the teachers for this. So it's reasonable that if you show the people the education that uses Cisco maps, maybe they are happier than you build by yourself map. But one of I have to say that, which is interesting, this is, for example, a VPN. This is just a network segment, you see? How they look different. And this is another great problem, because they look all different. So you look, this is another map. Private network. You see, this is very similar representation. This is another, how to say, overlay network, another way of representing the object. This is another way of representing the object, where you have the, how to say, different layers. You see, the site layer, the optical layers, the SONET SDH layer, and finally the IP layer, with all the devices. So we have to learn that our network infrastructure is simply from, how to say, maybe the point of view of the physical links. But this is not completely true, because we know that there is a strong, complex network just down our network. So if I want to display completely all the structure of the network, I have to explode a lot of devices, a lot of information. So on the top of the, so over the IP packet, there is a lot of infrastructure. And if I'm speaking about network topology map, why, in line of principle, I should forget about this infrastructure? From the other point of view, all this information makes the power of network maps, in some sense. But we need a way of, how to say, we really need a way of showing the network. Just this is another diagram. You see, this is a typical diagram about service provider. Okay, and with very schematic. Usually they want to see more than this. Each service provider has his own services and with the names well displayed so that everything is easily identified by them. So that's why I started talking about I know what I like and I like what I know, and just with a question mark over on that. So I will do the question later. So let's take just a look here. We have a comparison of network diagram software. This is also Wikipedia. Okay. Is my English understandable? Yes? Yeah. Thank you. Otherwise, I can ask Craig to translate. Sorry, it's a joke. So here, I don't want to see, so I don't like the fact that OpenNMS is not how showed as a network mapping software. Maybe it's not yet a network mapping software, okay? And you see that a lot of them are proprietary tools. At least this, I don't know so many of these, okay? But I taken a look, and each is very different from the other. Same problem.
We should update this, Antonio.
Sorry?
We should
We can do that. But here is the network mapping features. Okay? So, and you see map accuracy, view network devices, view port interfaces. So this is, these are all use cases in some sense. View physical connection by port interface, view VLANs, view virtual servers and clusters. Then there is another big feature, import data. This is less interesting because with OpenNMS you have a lot of such good features. Network scanning and discovery, scan network devices, scan network ports, interface details, scan, okay. But we do here, because these are more network management than maps. Here, view routing and information flow. Open service port, information. Can you read this one? Can do it better. Okay, routers by protocols. You want to see MPLF, WhereF, WHF, and so on. Okay, multicasting, manage change. So you can understand, and then there is some export and so on. How you say driving features, rack icons, physical servers icons, virtual server icons, storage icons, general network icons, Cisco network icons, network services. So this means if you have all this stuff to build a map. Okay, and you see yes, 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 no, and so on. Of course, you have a Microsoft Visio, but Microsoft Visio is just a stupid tool to drawing. I can just have a Picasso right in the networks, maybe better than the Visio. But he's dead, seems. In any case, that's how to say what we are speaking about. Okay? So, can the poor OpenNMS guys do something in this incredible situation? Well, let's go back to the slide. So, this is let's just, you don't know, this is Piero della Francesca. And this is Federico da Montefeltro and his wife, Battista Sforza. She died at 27 and she had 6 children or 7 children at that time. So, in any case, sorry, because, no, it's, you know, they say, what are you speaking about? I don't know, it's something like that. So, if we ask to Federico di Montefeltro to build the maps, he would do the right things, I think. So, let's go to which are our objectives. So, I have also to show something because another thing, we have the map use case. So, this speech is based on this wiki document, and I have also to say thanks. I wrote this document, okay? I wrote this document, but I got a lot of help in the conversation with the people in OpenNMS. Marcus von Ruden is a person here, and Craig Gallen too. So I'm boring the people about maps all the time, and sometimes someone asks, just tell me something about this. We don't have, at the moment, a technical solution for this. We want only to address some use case for in the future in OpenNMS. So the objectives are for OpenNMS 17. Okay. The first two were addressed. So we had an old service I wrote 10 years ago, and it was linked, and also I wrote the SVG map. So it seems that everyone wants to remove my code from OpenNMS. It's just, there is something, it's a task. It's an Uber task that says remove the code, but I'm strong guy, I wrote. And I have right access to the repository. So remove linkd and remove SVG maps. I have to say that we have a problem with the removing linkd is something that is well done because we have a replacement for linkd, is the announced linkd, but remove SVG maps is going to be a problem because we found that a lot of people have spent time in customizing SVG maps. Now I try to explain why Tarus, I come back to the beginning, says I hate maps. Because when he was very young consultant, he spent a lot of time in customizing the maps of OpenView. Okay, and it seems that with whichever technology do you have, if you don't spend time in customizing map, you cannot be really satisfied by this. I guess because spending all that time customizing map, you can say, of course, oh, they must be beautiful. You know, it's typically, you do all that time, should be okay. So we have now this kind of problems. So navigation between geomaps and topology maps. So we have geographical maps and topology maps. And also we have what we call the monitor locations. We try to use locations as hierarchy to replace the SVG maps, because the SVG maps was a hierarchical map structure. So you can, the user can create hierarchical maps, and then he puts everything on the maps and so on. So we need something to do this, and we try to do this with the location as hierarchy. So let's come back. So linkd is gone, so has been removed. And which are the differences between linkd and an linkd? It's 10 years, and 10 years is a lot of time. We made a lot of experience. So let me say, these are topology discovery. There are different ways of discovering topology, but we use S&P discovery. This means that network devices usually implements MAB, and you ask, and in this MAB there are also typical informations about topology. Okay? So, and you use this information to save the data. So the protocols supported are more or less the same. So Cisco Discovery Protocol, link layer discovery protocol, bridge discovery, transparent bridge discovery, OSPF, and ISIS. Okay, but the way in which it's done is completely different. And first of all, the enhanced linkd also saves to the database all the information related to the protocol. So we try to get the richness we need to have a better view of the objects on the network. Okay? In the past, we had a very simple, really simple object model in which we say, well, what is a link? It's just a connection between two specific OpenNMS nodes, two specific OpenNMS interface with IF index. Okay, so when I save the data in the old linkd, so it's, you know, standardization is very important. Okay. So I saved this information, but I lost a lot of the information that I just need to find this, because each of these protocols has a lot of information, the name of the port, the name of the device, the identifier of the device over LDP, CDP, and so on. So this is some richness that in line of a principle you have not to lose. And then if you want to use it in the maps, you can use it. Otherwise, no. Then we come back. But we have a lack. So we need in enhanced linkd or also in OpenNMS a new object topology objects. So new way of setting up the objects. We have some ideas. We have discussed about this, but this is mandatory. This means that we should a way of representing network objects. But the main fact about representing this network object must be also the way of grouping them. So we go to the next slide. This means that what makes a network object? It makes, for example, important if it belongs to a subnet, if it belongs to an SPF area, if it belongs to an ISIS area, if it's a BGP router or not. So all this information must be put, and also I have to create entities, structured entities over this. So I have the nodes, but on these nodes there are other entities. Why I want to create entities? Because I can display entities. So if I put, when I have a lot of information, okay, if I put all this information on the maps, I don't get nothing. It's impossible really to view what kind of information. Also, it's difficult to locate the objects. If you want that the maps should be a framework for the operators, they must be workable, and the most important thing is to find things on the maps. It's like, I don't know, you know, you have always search function and path functions. Okay, that's all what you have on maps usually. Just find me this object and find me this one. But, and it's a great problem, you know, I study in Italy, and I know, for example, where Bologna is. And it's difficult for me to say where is Mannheim. Also, if I have a map, or Mannheim maybe is a bigger town, but if it's a small town, Grossenluder, yeah? Or I don't know, whatever. It's very difficult. It's impossible. For a German guy, it's always true. Maybe he knows he's somewhere in some region. I don't know the regions. So finding the object, grouping the object is the fundamental, how to say, work to have better maps. That's what I think. Maybe I'm wrong. So we have also this topology map. So this was a huge work, more than 1 year work. And we have, I don't know if you worked on this, Marcus. I think so. You spent much time on this. I have spent some time, but I just work for what we call topology providers. Spend a lot of time in designing this topology map, because we had all this in mind. We had the classical, how to say, graph theory in mind, and we know that this was important. And we have, how to say, I want to stress about this only 3 points. We have, first of all, focal points. Then we have a semantic zoom level that is not a semantic zoom level. And then we have topology providers. I will try to explain why there is not. So the focal points is the point that is the starting point on which I build the map. Usually, we have no way, it's a node or more nodes. It's just, so if you can just view the node in topology map, it's just the focal point. Okay, so everything is displayed in relationship with this node. Our semantic zoom level is just the number of steps of links you have. So if you have 1, you just show on the map only the first connected device to the focal points. If you say 2, you find 2 steps, and so on. Okay? And then we have what we call topology provider. We have different topology provider for different views. And one is, I wrote at the time a topology provider for LinkD, and Donald Deslon wrote a topology provider for enhanced LinkD because it's completely different. And I guess Christian wrote a topology provider for VMware stuff, and so on. All this, in my opinion, must be unified. Okay, or just use the right topology provider with the right context. Okay, the topology provider are powerful because is an abstraction. So you can use, how to say, the maps with different source of data. And the source of data is the topology provider. I don't want to speak about too much about. So we have also geographical maps. And geographical maps are useful. Geographical maps have a very simple criteria for grouping nodes. It's just the distance. So if I have a zoom, how to say, I'm looking at the top, so I'm looking all the world, everything is zoomed by the number. So we have a very simple way of specifying this. So we put all the objects there in a place, in a circle. So if there is, they are in some range of distance. And when you focus, you get the details. We have no links, but it's not, it's nice because we got here into one problem, because the way is how we have to show links, how much links we have to show. Usually, you can have more than one link from the same direction, so from the different localities, going from the same way. So how much links I have to show, for example. And this creates another problem of how to represent other important objects in the maps that are links. Okay, this is it's like, I don't know, if you have a big picture of all Germany, and you are looking at the railways, only the most important railways are shown. And if you go into details, maybe you can see more other information. Something similar we have to create also here. Seems reasonable. Also, you know that we have a graphical convention for highways, for local street, and for regional streets, and for national streets. We know, just looking at so the streets and the railways are what we usually are the links. So we need also a graphical convention to understand the links. And also we need to decide which are the links to be shown and which are the links to hide when we are, how to say, zooming in or zooming out. Okay? It's something that must be done. So because the use case I have written there, the most important problem for me is that we understand in what kind of problems we go when we decide to have a network device maps. Okay, and why the people is so unhappy with them. Okay, these are a lot of issues we have actually in 16, and we have a problem with the enhanced linked topology provider. Because not all the information is displayed. Okay, non ci sono link, there are no links in geographical maps. Enhanced linked topology provider should be a layer 2 topology, at least, but lacks a lot of the old linked experience. So because we don't have a correspondent model to, how to say, ISIS and OSPF, or no, well, ISIS is a layer 2 protocol, okay? But OSPF is a layer 3 protocol. Then you should inherit from the layer 3 link, the understanding layer 2 link. There are a lot of problems like this. You can have IPv6 network, you can have a lot of other things strange. So also we found that an answered linked topology provider has performance issues, as reported by Mikkel. And also we need to improve our graphical conventions in topology map, because so that is the device identification is stronger. So is, how to say, is better. So I try just to explain this is a slide. It's simple. So we need to improve semantic zoom. Semantic zoom does not mean this. Semantic zoom means showing more or less details, not showing more or less connected device. And because, in fact, if you have thousands of devices with such a strategy, you can have all the devices on the map and you don't see anything clearly. So zooming in and zooming out means, in my opinion, is fundamental classification of the nodes and of the object. So when you zoom in, you focus on the physical node and on the physical connection. When you zoom out, you have to move from the nodes to different entities that must be represented as global entities. And you have to hide details. Otherwise, you are not able to see nothing. So if I'm zooming out, for example, of a router, I should, and this router belongs to an SPF area, I should look at the SPF area. If I'm zooming out on a router that is the default router of the local area network, I should get as an object the local area network, okay, to see how it's connected to the other. I don't really need a lot of information on this. So all such operation needs to be built somewhere in the code and and they live on the data that we have in OpenNMS. We have a lot of data in OpenNMS. We don't use really in the maps. So classification is fundamental to group nodes and links. So of course, then you also need to interact with the maps. We interact with the maps usually with the zooming in and zooming out, and also searching something or searching a path. Okay? That's what we do with Google Maps too. I want to go from here to here. They say, you want to go by foot or by car? That's okay, and we can just say something like that. I want to go from here to here. Do you want to go with IPv4 or IPv6? Or something like that. We know that these are the protocols that can connect places. Okay? I don't want to speak about this, but this is an idea of having a hierarchy of locations so that the user can tag the nodes with these locations. Okay, so you display, instead of looking at the distance, you look at the location, so identify, I don't know, country, city, country, state, and so on. Because we need something to replace the old SVG maps. So we need a way to the user to, how to say, create his own maps, simply tagging nodes. Layer 2 maps are what we have. Now, I told you that there is a great problem, and we have a lack of representation because we need more elements. One of these elements is the shared segments, is shown. So we have just only direct link. So the objects are direct linked to the other, and the shared segment is something different because a shared segment is a segment in which the people is connected to. It's different from if you have, for example, an app, you can just display this as a shared segment and so on. And also shared segment is something is important because this, I don't want to go into details, but this. So zooming in and out means you moving from nodes, shared segment, VLAN, LAN, MAN, and WAN. So all this showing the object. So this means that you should zooming out. So this is from the details of the nodes. Then you go to the VLANs if it is. Then you go to the local area network. Then you can see how the local area networks are connected between each other and so on. So that's the way you see the objects we want to create to be shown while I'm zooming out. Okay? Also, we should also have a functionality that will let us move from, how to say, the layer to the topology map to the geographical map. Of course, the topology map will put the device on the map, basically based on a logical algorithm. So I know what kind of network is this, and I put everything based on focal points and so on. In topological maps, the device, in geographical maps, the device are put on the map using their coordinates. Okay? But what happens when I go up? I should go up more, and then I can go to layer 3 maps in which I have different objects. You see, I can go zooming in, I can go to layer 2 objects, then I can go to subnets, then I can go to autonomous systems. All this kind of information is in OpenNMS, must be in some way displayed. So I can, for example, I can show at high level which are the autonomous systems and how they are connected. If you, for example, have 3-4 autonomous systems running in your network, or if you want to understand how is your connection with the neighbors. This of the autonomous system can be done using BGP. As there are some features of the BGP in which you can just inherit all the connections using the summarized routes and so on. So also we can have IPv4 and IPv6 map. It's completely clear that IPv4, IPv6 are two different protocols that can run over different links and also in different networks and so on. So, and then there is also always the problem in how to move from this kind of maps to geographical maps, of course. That's a nice question. So how to represent a subnetwork in a geographical maps or something like that, or an autonomous system. And also we have to move to an upper layer map. Which are the upper layer map? Are, of course, the interior gateway protocols map, like OSPF and ISIS. So if I'm the administrator of a wide OSPF network, I would like to have a map of this network and to identify the objects, which are the objects. There are a lot of details on the. So why all this information is important? Because when I have to draw the map, I have to take into account all this. So the algorithm for positioning the object on the map must take into account if it's an OSPF object or if it's ISIS. And if there is an SPF object, you have to put area 0 in the middle, because this is what Cisco does, everyone expects it. And so also you have to decide if you want to show, how to say, the border routers, border area routers, no, the ABR, area border routers, or just you want to show only the interior router when you are inside the SPF area. So just to let the information. It's all of these kind of crazy things have been written somewhere in that document, but it's just to say that, no question? Okay. It's just to say that we can, this is a big process, okay? We know all the problems related to this. Maybe we can have a good software design for doing this in the future, and I think we will take time to do all this stuff, as you clearly understand. And we hope also that will be a contribution. We don't know what to do. Maybe we want to set up a site in which we can have contributes about all this experience of networks and maps and icons and so on about representation. That's all. Questions? No questions? Any question?
Lots of things to talk about. So I suppose that, the actual issue we have here, before everything else, is we don't actually have a well-articulated network model. Before you implement anything, you kind of have to have modeled what it is.
It's the first point.
So that would be my first thing. You don't need to implement the whole model to start off with, but you do need to have a big view as to what things are and how they relate.
My idea, of course, a good network model is based on layering. So you should have, I really don't think it's, so what I have should have false, basic objects are, how to say, root. So it's just the physical layer. You cannot go down and top, and you can go up. Then you have several levels, and each level has, how to say, an aggregation of criteria in which you can say, so it's the way in which you can move from one point to the other. It's not all that much complicated, so you can have, but you can have a lot of strange things in this. For example, you should be able to, if you are designing a subnet, okay? In this subnet, there can be physical nodes and logical nodes. And also there can be, the physical nodes can be different from the logical node, and the physical node that holds the logical nodes is on another network. So you can have all such strange things. But at the end, you have always a dependency from the hardware. So you have a base that is the hardware. And then you have levels of abstraction, okay, in which that is software, API, something like that, I don't know, software, that in which the other things lives. So the model must be like that one, so that you should have a clear dependency and also a clear way of, so you have to tell, this object depends on this, okay? And also this object belongs to these other objects. So a way of dependency and grouping. And I don't think it's, and it's very general. So then we can say, well, we want to set up the layer 2 maps, no problem. So we know the objects for the layer 2 maps, that's all. And then we can say, well, let's set up the layer 3 maps. Then we say, we created the object subnet. And in this object, there is the criteria for starting from the nodes to get the information you have and so on. I really, so that's what I think about the object model. It's like, maybe 2 years ago, I spent some time in discussing this with Matt. And we have the same problem with the links. You know, this. We have aggregation of links too. And the links are related to also, because we have hierarchy also on interface. It's very, not too much complicated, but this dependency is just inside the nodes, because of course there is the physical nodes that has his operating system, his hardware. But over the hardware there are the interfaces, and there is the physical interfaces, and then you build upon the physical interfaces how many logical interfaces you want. Now, every, you know, if I look at the latest iOS version or to Juno's version, when you just configure an object, you always, the system automatically creates a logical interface for accessing it. And so, I don't think it's really too bad to let this work in practice. And the difficulties is to have a software design that is able to get the experience. So to recognize the objects, what kind of objects are, and to put in the right place. You know, so the object model is okay, but when you have an interface, you have a link on an interface, then you have to put, and if in this idea, you have to put this information in the proper place, or you have to inherit the information properly. Okay, it's like, it's just something like you have to build the hierarchies to better understand everything. When you build the hierarchies, it's okay, because you can go through the objects, and then you can group homogeneously. But the way in which to build the hierarchy, it's, in my opinion, has to be done with plugins. So it's just like, but well, let's put, or just with some bundle, SGI bundle, So let's put this part of information inside. Now, let's manage this, or let's manage this other one. Small piece of code. Not, it's very, could be, but this is our implementation strategy. We did not yet agree on an object model. We don't have, it's just, there are use cases. So it's some wishes. We know that we can address these wishes. We want to address these issues in the future. And there is, we are discussing about this and this. So I hope that everyone would give a contribution to this. That's why I made this map use cases, because of course users matters. So if you are interested in network topology, you're invited to contribute on the wiki page with your observation and whatever else. Okay. Thank you.